teacher!
Hey guys, today we're going to be doing 5.2 graphing a line from a y equals mx plus b equation. You've only known how to graph from a table of values really, and now we're going to figure out how to do it if you just have an equation. So the first thing is that when you had the table, your x values are always on the horizontal axis, and they're usually first in a coordinate pair, and then your y-axis is on the vertical axis. So if we had to write it as a coordinate pair, for example, which number should come first? It should be the x value, in this case it's 1, and then the y value, in this case it's also 1. And then the way that you can remember this is it's in alphabetical order. It's x, y, and then z if you wanted to, but coordinate pairs are always in alphabetical order. It's when you start getting into the slope formula that people start getting mixed up. So here we have an equation, y equals 2x plus 1, and we have a set table for x. How do we figure out what to do for the y values? You take the equation and then you see how you have variables, and we already know that variables are things that keep changing. So in this case, if x is equal to -2, then y is going to be the answer to the substitution of having -2 for x. So we would have 2 times the x value, which in this case is -2, plus 1, and then that answer is our y value. So in this case it would be -4 plus 1, which is -3. And then you keep going down the line and doing the same thing. We recopy everything except that x value. The x value is the thing that keeps changing, because in the equation that's what's changed. And then you just write the answer to whatever that answer is. So in this case it would be -1, 0 would be 1, this one would be 3, and this one would be 5. And a lot of you would be able to also see the pattern as well, and you don't even have to substitute it into the equation. But to get you started, you should probably substitute it first and then figure out what the pattern is. So here we're going to plot our points, and we have -2 and -3 is the first point. So the x is on the horizontal, and we have to go to -2, which is here, and then the y value is -3. So that's our first point, and then -1, -1, 0, 1, 1, 3, and then 2, 5. And you can see that we are doing a nice straight line. If one of your dots is not going in the line, that probably means that you did something wrong, because this whole unit is going to be linear relations, so it's all going to be lines, and so you can see they all line up perfectly. So that's the first example. So here we don't have a table of values, but we have a general equation in y equals mx plus b form. And if you remember, in y equals mx plus b, let me just write that in, y equals mx plus b. The m stood for slope, exactly, if that's what you said. And then the b value stood for the y-intercept. So anytime you're given an equation, you can immediately plot one of your points, and that is the 5, because this one is our y-intercept. Y-intercept is where the line crosses the y-axis, and in this case it's at +5, so I would just draw a dot right there. And then slope is rise over run if you have a graph, and if you don't, then there's that y2 minus y1 formula that we always use. But because we're doing a graph, it's easier to figure out the rise over run. So in this case we have -3/2, and remember that the negative only applies to one of the numbers, and you can choose. So in this case I'm just gonna make it go with a 3 to make it go down 3, and then this one will be positive, which means I'm going to the right. So I'll go down 3 from here, 1, 2, 3, and then I'm going to the right because it's +2, 1, 2, and then this is where my new dot is. Now, if you had put the negative with the 2, you would have gone to the left and up 3, and then you also would have noticed that you would have been probably somewhere up here. So if you find that you're going off the graph, then you should switch around the order so that you can fit and properly put the point on the graph. It'll be easier for you. And then if you really know what you're doing, you would have realized I have forgotten my arrowheads on all of my lines because they go forever. So I got to put my arrowheads, and you should make sure you do your arrowheads too. So that's how you can graph without a table of values. It's actually much faster to do it without a table of values. So another example, in example 3, we have y equals x minus 4. Now it's easy to see that our b value is negative 4, but it's harder to see where on earth our slope is. I don't get it. We're supposed to have y equals mx plus b, but there's no m value here. But miss, there's an invisible 1 in front of the x. Yes, exactly. There's a 1 as the slope, an invisible 1. So you know that you have to go up 1, but then what do I have to do to go to the left for the run of it? And then again, if you recall, all whole numbers are technically fractions. All of them are over the denominator of 1. So anytime I have a slope of 1, it's the same as going up 1 and to the right 1, because this is positive. So I'm going to plot my point at negative 4. And then because the slope is 1, I'm going to go up 1 and then to the right 1 because I'm getting more positive. And then that's my other point. And then I have my 2 points, which means I can immediately start drawing my line. And then I'll put my arrowheads as well because I keep forgetting to do arrowheads. And it's also a good idea to extend your line out when you're drawing it. A lot of students will make their line super duper short, and they'll be like, oh, there's my line like that. No, you don't really want to do that, because sometimes we'll ask you interpolation or extrapolation questions. It's like, what's the value when x equals 5? And you're like, I don't know, it doesn't show me. Well, it's because you didn't draw your line long enough. So extend your line usually to take up most of the graph if you're graphing. And then example number 4 looks even more strange. You've got y equals negative 4, which doesn't look at all like y equals mx plus b. So can you figure out the only thing that they gave us? They only gave you the b value, which is still negative 4, and then this becomes one of our special cases. I'm not sure if you'll remember it from the Desmos investigation, but if y equals negative 4, that means that my slope is technically 0, because anything times 0, x times 0 is still 0. And this became the special case of those horizontal lines. It's a flat slope because every single value of x is negative 4. So this dot is 0, negative 4. This dot is 4, negative 4, and so on and so forth infinitely. Even if x was 10 million, it would still be at negative 4, and that's why the x doesn't exist, because it's redundant. Every single value of x, the y value is going to be negative 4. So this one was a special case here. And then finally, in our last example, this one's the weirdest one of all. Oh my gosh, y is gone. What the heck happened to y in y equals mx plus b? So this should be like a warning in your head that this is another special case. Can you guess which special case it would be if x is equal to 3? If you said it's going to be a vertical line, then you are correct. Before we had y equals something, and that was horizontal, and this is the opposite, where x equals x equals 3 for every single value of the y's. And I don't know if you remember what the slope is. What's the slope of all vertical lines? It is undefined. If you put it in your calculator, if you had a slope of some other questions, you'll have like 3 divided by 0 or 5 divided by 0, and you'll get an error in your calculator, and that's because it's undefined. So all vertical lines are undefined. And that's how you graph lines from an equation.